Hello. Today I want to teach you a concept about supply chain. So what is a supply chain? So supply chain basically is a manufacturer selling to a retailer to a customer. So actually in real world, the supply chain will be more than two tiers. It can be a factory going to a manufacturer, to a distributor, to a retailer, and then to a customer, so on and so forth. So today I just want to approximate it with a two-tier supply chain. So let's say a manufacturer produce a product at a production cost of C, and then the manufacturer sell the product to the wholesaler, to the retailer at a wholesale price W. And then the retailer use this product and selling to the customer at price P. So the question that we want to address is what should the wholesale price and what should the retail price be? Know that the production cost is basically not a decision because that is a material that you get from the market and you don't get to decide how much the production costs, but you get to decide how much to sell to the wholesale price, and you also get to decide what is the retail price to the customers. And then there's a demand function 1 minus P, which is exactly the same. Now there are two different firms. So therefore, there are two different profits. For the manufacturer, so the profit is profit M. Profit M equals to W minus C multiplied by demand. So W minus C is the profit margin for the manufacturer. For the retailer, the profit is profit R, which equals to P minus W multiplied by demand. So P minus W is the per unit cost. So then what we use is a technique called game theory plus supply chain. So game theory applied to supply chain. So then in game theory, there are three things that is very important. So the first thing is the profit function. Profit function in our case would be profit M and also profit R that I presented in the earlier slide. The demand function. So the demand function equals to 1 minus P, which is something that I presented in the previous slide as well. So the new thing that we have is a game sequence. So what is a game sequence? So there are three components. What is the decision? Who makes the decision? And also, when is the decision being made? What is the decision? Who makes the decision? And when is the decision being made? So then, what is the decision? So there are two different decisions, W and P. W is the wholesale price. P is the retail price. Who makes the decision? So we have a manufacturer, we have a retailer. So the decision is made by one of these two firms. And when is this decision being made? So then there are four possibilities. Okay, so we have a manufacturer, we have a retailer, and there are two decisions. So there are four options. So the first option is a typical way. So the manufacturer decides the wholesale price while the retailer decides the retail price. So the manufacturer first decides the wholesale price, and then the retailer decides the manufacturer first decides the wholesale price, and then the retailer decides the retail price afterward. So this is option one. It's the more typical way. But then there are other options that is also possible. So let's say you are a retailer, you want to sell, you have some idea, a proof of concept that you want to sell to the customers. So then you have a convention that you have a press release telling customer that I now have a good idea about new product. I am going to charge a price P. Okay, so then the customer think that, wow, this is an interesting concept. Then you outsource this production to the manufacturer, and the manufacturer charge the price W. So that is option 2. Okay, so the retailer first have a press release telling other people that there's a good concept with a price P. So therefore that takes place in step 1. And then the retailer outsources this idea to the manufacturer, and the manufacturer produces this product at price W. So that is option 2. We also have option 3, where we have a very powerful manufacturer. So let's say Apple produce iPhone. So it would be reasonable to think that Apple, which is the manufacturer, sell the product to some small retailer on the street. And then a small third-party retailer does not decide the price of the iPhone. Instead, this is the manufacturer decides the wholesale price. So therefore, Apple would decide how much wholesale price to sell to this small retailer. The manufacturer, which is Apple, also decides on how much retail price that the iPhone should be sold for. The last option is a very powerful retailer. So Walmart is a very powerful retailer. So Walmart have a private label that it asks a manufacturer to produce. In that case, Walmart would set the wholesale price and also the retail price as well. So as you can tell, the Walmart is a very powerful, and it can decide how much price the wholesale price and the retail price can be. So as conclusion, what I want you to learn is that the game sequence, which consists of 3 components. What is the decision? Who makes the decision? And when is the decision being made? What is the decision? Usually there's only one right answer. Let's say the wholesale price and the retail price. But who makes the decision? And when the decision being made, there are many different answers. It depends on what is the story that you want to tell. If the story you want to tell is a typical story, then the game sequence would be option number 1. But if you have a story, the story is that the retailer first have a proof of concept and ask a manufacturer to produce the product, then the game sequence will be option 2. If the story that you want to tell is there's a very powerful manufacturer, which is Apple, then the story, based on the story, you should use option 3. And if the story you want to tell is a very powerful retailer, such as Walmart, then based on the story, then you should use option 4 as the game sequence. Okay, so there's no one correct answer. It depends on what is the story that you want to tell. So right now, what I want to do is to consider option number 1. Option number 1, and I want to find out what would be the optimal wholesale price and the optimal retail price for this particular problem. So let's go to Mathematica. Okay. So let's open up Mathematica. So now I want to input several things. Demand equals to 1 minus P. Profit R colon equals to P minus W multiplied by DD. Okay, let me zoom it up. Make sure you can see. And then profit M colon equals to W minus C multiplied by DD. Remember, every time you have to do colon equals to. Okay, so I have not yet pressed Shift Enter. So therefore, everything is still in blue. But right now, I do Shift Enter. So I have DD colon equals to 1 minus P. So DD right now becomes black because DD I assigned a value 1 minus P into DD. Profit R also becomes black because I assigned the value P minus W multiplied by DD into profit R. Same thing, profit M is black because I assigned W minus C into DD. Okay, for my exercise, I want to keep things simple. I want to get C equals to 0. Okay, I do a simple case. And then what we have to do is an idea of backward induction. Backward induction, that means you go from the end, go back to the top. So let's go back to the game sequence. So the game sequence right now is option number 1, the typical way. R decides P would be the last step. So therefore, the backward induction, I first solve for what is the price that the retailer charge, assuming there's a W. Then I would solve for what is the wholesale price for the manufacturer. Okay, that is called backward induction. Let me show you what I have to do here. Okay, so then right now, let's say you are a retailer. For a given W, what should the price be? You are the retailer. For a given W, what should your price be? So as what we have done last time, I take the derivative of profit R with respect to P. If I do Shift Enter, I have this value. Then I solve for this value equals to 0 as a function of P. Okay, you are the retailer. You want to find a price that optimal your profit. So just like what we have done last time, the picture of profit R would be upward and then downward. It would be a concave shape, going up and then going down. So I want to find out the slope equals to 0. So the slope is 1 minus 2P plus W. I want to set 1 minus 2P plus W equals to 0. And then if I do Shift Enter, I have P equals to 1 plus W divided by 2. So let me plug in this value into my function. Okay. Okay, good. So P colon equals to 1 plus W divided by 2. Okay, bye-bye, okay. And then, yeah, that is my son coming up. Bye-bye, Jordan. Okay. Okay, so now we have profit. And let's look at what is the value of profit R and profit M. So profit R now equals to a function looks like this. And profit M now equals to a function looks like this. So as you can see, this is a little bit messy. So let me try to simplify it. To simplify it, there is a command called factor. So factor command would help you to factor this function so that it looks a little bit nicer. If I do factor profit R, it have a function 1/4 multiplied by 1 minus W squared. Same thing. Profit M. Then I have this value. So let's try to understand something about this picture. Okay. So what I want to plot is profit R as a function of W from 0 to 1. So profit R as a function from 0 to 1. So on the x-axis, we have the wholesale price. On the y-axis, we have the retailer's profit. So what it says is that as the wholesale price increase, then the retailer have a lower profit, which completely makes sense. Okay, so if you're the retailer, then the manufacturer decides on the wholesale price. If the manufacturer set a wholesale price equals to 0, then you make a lot of money. But then if the manufacturer set the wholesale price equals to 1, then you make 0 profit. So which completely makes sense. So you are the wholesaler and you are the retailer. You hope that the manufacturer would set a wholesale price equal to 0 or as small as possible. Unfortunately, you do not control the wholesale price. It is the manufacturer that controls the wholesale price. So therefore, even though you hope that the wholesale price equals to 0, but the manufacturer is not going to do it. Let's look at what is the manufacturer incentive. Okay, now I plot a picture which is the manufacturer's profit as a function of wholesale price, where the wholesale price changed from 0 to 1. And this is the picture. So on the x-axis is the wholesale price. So let me try to explain what it meant. When the wholesale price equals to 0, then the manufacturer earns 0 profit. The reason is that the manufacturer's profit is W minus C multiplied by DD. So right now C equals to 0. So that means the manufacturer profit is W multiplied by DD. So of course, if the wholesale price equals to 0, then the manufacturer makes 0 profit. Let's look at what happened when the wholesale price equals to 1. So when the wholesale price equals to 1, then the manufacturer profit is 1 multiplied by DD. Let's look at what the retailer would do. Okay, so in this line, so that would be what the retailer would set as a retail price when the wholesale price equals to 1. Okay, when wholesale price equals to 1, then the retailer would set a retail price equals to 1 plus 1 divided by 2, which is equals to 1. So wholesale price equals to 1, the retail price also equals to 1. When the retail price equals to 1, let's look at the demand. When the retail price equals to 1, then the demand equals to 1 minus 1 equals to 0. So therefore, if we look at this picture, when the wholesale price equals to 1, the retail price also equals to 1, and the demand would equals to 0. So therefore, the manufacturer earns 0 money because it gets 0 demand. So the optimal is somewhere in the middle. So now we have to find out what is middle. So we do exactly the same thing. We try to find the slope. So D profit M W. Okay, so the profit M as a function of W, which is this graph. Okay, this graph. I want to find out when is the slope of this graph equals to 0. So the slope of this graph is this. And I want to compute when this value equals to 0. So once again, I do the command solve. So I highlight this equals to 0, comma W. So what this does is to tells me that at what value of W, then the wholesale price would equals at what value of W, then the slope would equal to 0. So if I do shift enter, then that would be 0.5. So that means the manufacturer would charge a wholesale price of 0.5. So this value is 0.5. Okay. So let me input this value. So what we have learned is that the manufacturer will charge a wholesale price W equals to a half. This value would maximize its own profit. So when the manufacturer charge this, what would be the retail price? So let's check. P. Earlier, we have already computed P equals to 1 plus W divided by 2. Then all we have to do right now is to do shift enter. And we find out that the price is 3/4. It means that when the manufacturer charge a wholesale price 1/2, then the retailer will charge the price 3/4. The demand would equals to 1/4. And then the profit of the manufacturer equals to 1/8, and the profit of the retailer equals to 1/16. So I want to point out something very interesting. Last time when we do an exercise, first exercise, okay? So what we have done is that a manufacturer selling a product to the customer, there's no supply chain. Manufacturer decides on the price. We have done some exercise when the production cost equals to 0. In that exercise, production cost equal to 0, then the price would be 0.5. Demand equals to 0.5, and the manufacturer's profit is 0.225, which is 0.25. So 1/2 multiplied by 1/2 equals to 1/4, which is 0.25. Let's look at a supply chain. When there's a 2-tier supply chain, what we have find is that W equals to 0.5, but then the price is 0.75, 3/4. Okay, so in a single tier supply chain, the customer will look at a price that is 0.5. Now the customer would see a higher price. How high? Which would be 0.75. With a higher price, the demand decrease. For a single tier supply chain, the demand is 0.5. Now the demand becomes 1/4, which is 0.25. For a single tier supply chain, the manufacturer have a profit of 1/4, which is 0.25. Now, the manufacturer have a profit of 1/8, which is 0.125. And the retailer have an even smaller profit, which is 1/16. if we want to look at the supply chain profit, which is profit M plus profit R, so that is 3 over 16. So 3 over 16, which is, we have a command N 316. So N, it in Mathematica, that means it computes the numeric value, okay? The numeric value of 3 over 16 is 0.1875. So we have an interesting finding. The interesting finding means compared to a single tier supply chain. First, we find out that the retail price would be higher for a two-tier supply chain. Second, we find out that the demand is lower for two-tier supply chain. The manufacturer and the retailer and also the supply chain profit are all lower for two-tier supply chain. So I'm going to stop here, and what I want you to do is to do an exercise. For this exercise, I make the assumption that C equals to 0. What I want you to do right now is to do this exercise again, but then assuming C, okay? Assuming an algebraic value of C. And then after you are done, I want you to let me know before I move on to the next exercise.